Hello guys, welcome everyone to the PyTorch lecture number 2. Today we'll be walking through gradient descent, and yes, in the last lecture also I gave you some glimpse of it, but today we'll cover that in depth. So guys, before covering the code, I'll try to just show you everything by hand. So guys, the first thing is that you need to define a function. Okay, so here the function that I'll be taking for this example is x square. So I'm going to just write it out, x square plus 2y square. Okay, now see guys, the first step is nothing but taking derivatives. Okay, everything would be shown by code as well, but let's just take derivatives. That's done. Now initially the value of x is 4 and initially the value of y is, let me see what the value of y is, it's 2, I guess. It's 3. So initially the value of x is 4 and y is 3. So I've taken the derivatives. So guys, I have been saying to you this in the NLP series that we'll have a loss function. Okay, we need to find the optimal values of weights, optimal value of weights in such a way that our loss function gets minimized. Okay, so that's part 1 of the story. Part 2 of the story is that you know how to compute basic derivatives. Okay, whenever we are dealing in terms of neural net, specifically uh, your partial derivatives are computed, and all that thing would be handled by PyTorch only. There are few minor things which you need to know, not entirely, because guys, visualizing that chain rule becomes difficult, but for the time being we can skip it. We just need to focus on the basics and how to get stuff done. So see guys, now the thing is, we have a function z is equal to x square plus 2y square, and we have taken derivatives as well. I think you're able to understand this much derivatives. Now the next thing is guys, you need to update x. So what is x? So x is x old minus rate of change of loss with respect to x old into the learning rate. So guys, let's assume the learning rate is 0.1. So x is 2x. So what was the value of x? Was 4. So x is 4 minus rate of change of this is 2x, this is 8 into 0.1. So x is 4 minus 0.8, x is 3.2. So guys, if you're able to understand this calculation, you will be able to understand every bit of it. This is how it happens. So let's say for y, so y old minus learning rate of change with respect to y. So what is y? Y is 3 minus 0.1 into 4y. So 4 into y, what is y? Y is 3. So 3 minus this would be 12, because this is 4y. So 4 into 3, 12, and then this would be 1.2, and then you would get 2.8. So guys, I may do some calculation wrong, but I hope you're able to get the essence of it. The essence of it is that how you would approach it in PyTorch, I'll be showing you, but it's just for your basic on how gradient descent happens, that there's a loss function and you need to find optimal value of x such that that loss function gets minimized. And for that we are using gradient descent, in which we take derivatives and then try to just move in the direction of the derivative, or perhaps the direction of against that derivative, in order to find the minima. But more or less this is a PyTorch series, so let's just quickly jump into PyTorch and try to understand how things are happening actually, specifically from a coding perspective. So guys, just try to see line by line. I'll explain every code, nothing would be skipped. That's the promise of me when it comes to this PyTorch series. It would be very crisp, very concise, and you would know everything when to apply. So guys, we have created two tensors. In the last lecture I told you tensors are the basic building block of PyTorch. I have fixed the learning rate. Then I want to find the minima of this function. Assume this is our loss function. Then guys, we are starting at x dot item, y dot item. So what does dot item does? It just extracts a numerical value of the tensor. Okay guys. Then guys, we are just storing history, which is okay. Now we are starting with the for loop. We are defining the function, then dot backward. Last time I taught you, it computes the gradient. Then guys, we are setting up torch dot no grad, because guys, we don't want to track our gradients. And then we are updating x like the way I showed you. So it's just like x is equal to x old minus learning rate into rate of change of the loss function with respect to x. So I gave you a demo as well, right? So we have this, then we are printing the value at that subsequent point, then we are storing the history, and then guys, we are just resetting the gradients because PyTorch accumulates gradients, so we need to clear them each iteration. So see, you had this, we had this. I gave you a glimpse of how we got this 3.5. So I didn't get 1.79, rather I got something else. I got, I guess, 2.8. Yeah, that was right wrong guys. 3 minus 1.2 is 1.8 only. So in PyTorch it's coming out to be 1.7999. So you are able to understand. See, I showed you by hand as well, and the same thing gets matched over here as well. Let me just share this screen as well. See, it's 1.8 only. So you're able to see guys how with the dot item we can just extract the numerical part of the tensor, and rest everything is fixed. So you're able to see how from hand I showed you calculation, then I showed you that okay, we need to remember dot backward. Then this is also very important guys. We need to disable gradient tracking so that we don't track gradients during parameter update. It makes the process quicker. And then guys, we are just updating the weights, and then we are just resetting the gradients because PyTorch just accumulates gradient. That's how it works. So for the time being, this much is enough specifically for back propagation. And guys, we'll be starting to cover a lot of downstream tasks as well, starting with regression and all. So please stay tuned in this series and have a great life, and please subscribe to my YouTube channel. Thank you guys.